Hi everyone, welcome to this live session on time, speed, distance. Now what we've decided to do is basically we'll take a one topic and we'll try and do the 5 best questions of CAT around those areas. So today we'll be talking about time, speed, distance, and we'll be looking at not 5 but maybe around 7 PYQs. I know some of the students have also asked their doubts over here, but understand that maybe some of these doubts I cannot solve it on YouTube because I don't know the source of the question. They could be somebody else's question, so it's plagiarism and I cannot use those questions. So I will not be able to solve those doubts. Maybe you can ask them to your faculties or whatever. Okay, so now let's first talk a little bit about time, speed, distance in general. Now when I say time, speed, distance in general, what do I normally mean? Basically, when I'm saying time, speed, distance, it will be a part of arithmetic. To do time, speed, distance well, I would always recommend that you know your topics of percentage, ratios, variation very well, and learn how to use them also over here. Once you're able to use variation all in time, speed, distance, it makes a lot of difference. Let's talk about the importance of time, speed, distance. How important is time, speed, distance? Very frankly, I haven't seen a CAT paper up till now where there was not even a single question of time, speed, distance. I can always say that there was never a question of permutation, combination, there was never a question of logs, somewhere or the other there was never a question of indices or any topic like that, linear equation, quadratic equation, but time, speed, distance, I have never seen a paper without time, speed, distance. Time, speed, distance is always present. And for the last couple of years, I would say at least 2 questions and sometimes maybe even 3 questions of time, speed, distance are asked. So you can assume at least 2 questions are asked. What we are going to try and do is we are going to try and take some areas out of time, speed, distance today and maybe do the session today and maybe do one more session after some time live on time, speed, distance where we look at races. I haven't taken too many questions on races today and maybe we'll do that as a separate session. Okay, so let's start with the questions now and we can start with the first question. Y'all can keep having a look at it and then also if there are any queries, we'll answer them in the chat box. So this is and I've also tried to take the questions of the last 4-5 years ka CAT, not gone too old into CAT 2008 or something like that. So CAT 24 is the first question which was there last year itself. A bus starts at 9 and follows a fixed route. So normally the fixed time which is there is not a very important thing right at the start. I'll need this maybe towards the end of the question, okay, because the end of the question is the scheduled arrival time of the bus is what. So basically I will have to find the time for which the bus is traveling and add it to 9 a.m. and get the answer. So the 9 a.m. is not something which I'm going to use now. One day it traveled at a constant speed of 60 km per hour and reached its destination 3.5 hours later than the scheduled arrival time. So suppose it had planned to travel in T hours. The original plan that was that the bus will travel in T hours. But because it was traveling at 60, the bus took 3.5 hours more. If I open this bracket up, which I will not do, this becomes my total distance. 60 multiplied by T plus 3.5 becomes my total distance which the bus will have to travel. So logically, again maybe not needed for this question, but logically you should understand traveling at 60, it took 3.5 hours more than the scheduled time, which means the actual speed to reach on the scheduled time should be more than 60 also, okay, because you want to take less time. So if your speed is more, time will be less because distance is constant. Next day it traveled 2/3 of its route. 2/3 of the route means 2/3 of the distance in 1/3 of the time and the remaining part at a speed of 40 km per hour to reach just on time. Now let's read the second part very carefully. So it traveled 2/3 of the distance in 1/3 of the time, right? That's what they have said. Can I say therefore the 1/3 of the distance it traveled in 2/3 of the time? Let's go through this one more time. It traveled 2/3 of its distance in 1/3 of the time. So whatever time T hours were supposed available, so it took 1/3 of the time to travel 2/3 of the distance. So now can I say when it traveled at 40 to do the remaining 1/3 distance? So 1/3 of the distance at 40 will take 2/3 of the time, and that should be your equation. Now we know distance is speed into time, so 1/3 of the distance is this 60 into t plus 3.5 will be equal to speed into time. Speed is 40 and time is 2/3 of t. The actual time was t, right? So the time over here will be 2/3 of t. Let's start cutting out. 0, 0 cuts out. 3 1s are, 3 2s are cuts out. Nothing else is cutting out. So this 3 will also go on top. So I'll have 3 2s are 6t. 6 into 3.5. How much is 6 into 3.5? That should be 21. Will be equal to 8t. And therefore 2t will be 21 and t will be 10.5. Did we want that only? Yes, we wanted that only. If they had asked the distance also, we could have found out, because we had this equation where we could have put the distance, we could have found the distance, but not needed. We wanted the time. Now, what will be the time? 10.5 hours from 9 a.m., which means instead of 12 hours, 1.5 hours backward. From 9 a.m., if I am going to 9 p.m., it would have been 12 hours. 1.5 hours before that will be 7:30. So answer will be 7:30 p.m., which is the first option. Understand what are the other things they could have asked you in this question. They could have asked you for what is the total distance the bus has to travel. This would have been the answer. 10.5 plus 3.5 would be 14, and 14 into 60 would be the answer. They could have asked for what is the actual speed at which the bus should travel to reach on time. So you now know the distance. You know the time is 14 hours, so you can calculate the speed also. So lot of different things they can ask. So understand the question, what happens in time, speed, distance, no? There's always a story. There's always that story where the bus went from here to here, the A went from here to here, or B went from there. In your mind, just make that story well, understand who's traveling from where to where, and that's very, very important in time, speed, distance. So that's the first question. I'll just give you a couple of seconds to have a look at it. By the time, I'll see if somebody is asking any queries in the chat. Just open it on YouTube now. So we'll start with the second question by the time the YouTube gets opened on that instrument. So let's start with that. Now the second question was a slightly difficult question, CAT 23 question, a slightly difficult question of CAT 23. Upstream, downstream, boats, but upstream, downstream and boats can also be a difficult topic. So let's understand that. Yeah, so I'm also having a look at the chats, as I said. Okay. So Harsh, Tanya is already asking, sir, how did 2/3 T come? Now, they had said that 1/3 of the time has been used up, Tanya. In the previous example, they had mentioned that 1/3 of the time is used up. So if 1/3 of the time is used up, do you agree that 2/3 of the time is remaining? And that is how the 2/3 T came. I hope that is clear, Tanya. Okay, great. Let's go ahead. So yeah, I was talking about the next question being a slightly difficult question. Simple concept, both upstream, downstream. A lot of people think, oh, upstream, downstream is very simple, and how can the question be difficult? This was one example of a difficult upstream, downstream question. And if you'll have a look at a couple of IFT papers also, there were a couple of difficult upstream, downstream questions earlier. So let's have a look at this. Sorry. A boat takes 2 hours to travel downstream a river from port A to port B. So A to B is downstream, and 3 hours to return to A, which obviously will be upstream. So A to B is downstream and B to A is upstream. Now this is a slightly longer question. So what I've done is I've already put down the solution. So because there's no space to write there. If the speed of the boats and the river are constant, sorry, there's one more boat, another boat takes a total of 6 hours for the return journey. That means goes from A to B and comes back in 6 hours. And if the speed of the boat and the river are constant, then the time in hours taken by the slower boat to travel from A to B is what? Now, looking at the options itself, you all should have told yourself in an exam situation, this looks like a difficult question. I should ideally not attempt it in my first round. And that should have been your strategy for this question. So let's start with the regular approach. Normally, the normal approach which I always use, let the speed of the first boat be A, let the speed of the current be B, and let the speed of the second boat be X. These are the three things in the question: speed of the first boat, speed of the second boat, and current. Now, what do we want to do? Let's look at the first case. So, downstream, the speed will become A plus B for the first boat. Downstream, the speed will become A plus B. In 2 hours, it is able to do the whole distance. So, can I say 2 multiplied by A plus B will become the distance? 2 is the time, A plus B is the distance. And same thing in the return journey is able to do in 3 hours, which is upstream. So, that time the speed will be A minus B. So, it will be 3 into A minus B. Open the brackets up, solve everything. So, if you bring all A's on one side, all B's on one side, you will get A is equal to 5B. I am sure you will be able to solve this on your own at least. So, we have got A is equal to 5B. Once we got A is equal to 5B, let's put A in any one of them. That means either here or here, anywhere let's put the value of A. Suppose if I put it in the first case, so what will I get? 5B plus B is 6B, 6B into 2 is 12B. So, can I say my total distance between A and B is 12B? I'll repeat this. The distance between A to B, one-way journey, is 12B. I've got the distance in terms of B. Great. Let's read further. Now, the second boat. Let's come to the second boat. Second boat speed is X. Speed of the current is still B. So, while going downstream, the speed will be X plus B. While coming upstream, the speed will be X minus B. Now, we know distance is 12B. So, can we form this equation? Let's have a look at this very carefully. 12B divided by X plus B will be what? That will be your time taken. Time is distance upon speed, right? So, 12B upon X plus B, time taken in downstream plus time taken in upstream is equal to 6 hours. Now, this is the equation we have where we have a relation between X and B. Let's solve this. Let's take LCM. So, 12B into, or first I'll just divide by 6. So, I'll get 2B upon X plus B plus 2B upon X minus B is 1. Let's now take LCM. So, I'll get 2BX minus 2B square plus 2bx plus 2b square, and cross multiply the denominator on the other side is equal to x square minus b square. So, if you multiply these two, it will become x square minus b square. So, minus 2b square and plus 2b square will cut out. Let's form the quadratic properly. We will have a 4bx. 4bx is equal to x square minus b square. So, we will get 0 is equal to x square minus 4bx minus b square. Now, this is a quadratic where there are two variables. So, which means if I solve for x, now listen to this very carefully. If I solve for x, I will get x in terms of b. So, in short, I will get a relation between x and b. This quadratic equation, now that is why the options were bad, because this quadratic equation is a little bit difficult to solve. So, we have got x square minus 4bx minus b square. I will look at the chat post the question is done. Okay. Now, let's take this equation and solve this. So, how will you solve this? You will have to use the formula method. What is the formula we know? For quadratic, x is equal to minus b plus or minus root of b square minus 4ac upon 2a. Let's apply that formula. So, x is equal to b minus b. B itself is minus 4b, so that will become plus 4b. Plus or minus b square will become 16b square plus 4ac will become 4b square upon 2. 2 ones are 2. Solve that. 16b square plus 4b square is 20b square. What will be root of 20b square? 20 is 4 5s. So, I can bring 2b outside and root 5 as it is. I hope you all got this. Square root of 4 will be 2, square root of b square will be b, root 5 as it is. So, we will get x is equal to 4b plus or minus 2b root 5, and hence now I can take 2b common and 2 can cut out. So, I will get x is equal to b into 2 plus root 5. Skipping a few steps, I hope people are getting it. So, x is 2 plus root 5. Now, once we got the value of x in terms of b, what do you want to find is very, very important. Pay attention to what you always pay attention on what have they asked at the end. In ours, what is the time taken by the slower boat to travel from A to B? Now A to B was downstream. That means I want to find 12B upon x plus b. This is what I want to find. 12B upon x, slower boat is this one. How do I know this is the slower boat and not the earlier one? Because for the earlier one, though, the question values were already given. So this has to be the slower boat, and the earlier boat was taking 2 plus 3, 5 hours, while this boat is taking 6 hours. That is why I know this is the slower boat. So if I bring b down over here, I get x upon b is 2 plus root 5 upon 1, which means I can assume x is 2 plus root 5 and b as 1. I can assume, okay, because I want to find a ratio anyway. So 12b, if I assume b as 1, so 12b will be 12 ones are 12 upon x plus b will be 2 plus root 5 plus 1, that is 3 plus root 5, and then we will rationalize it. So multiply by 3 minus root 5 upon 3 minus root 5. What is 3 plus root 5 into 3 minus root 5? A plus b into a minus b, 9 minus 5, 4. So if you solve this, 3 plus root 5 into 3 minus root 5, you will get 4. 4 3s are 12 will cut, and this will be your final answer, which is the fourth option. Go through it carefully, take a minute, understand it. Definitely was a level C question. In an exam situation, you should not be attempting such questions. Why? Because, see, look at the options itself, or at least it should not be a question which you should have done in your first round. That's how I would look at it. Now, the only myth I wanted to break over here with this question was, it is not necessarily that boats and stream will always be a straightforward question. Okay. So by the time I have a look at the chat and what people are asking, you all can just have a look at the question. So Khushi's got a query saying, sir, I'm not able to solve time, speed, distance at all. Khushi, as I said, you'll have to start thinking of the story very carefully, very slowly, make diagrams if necessary. For example, this question did not need a diagram, but some other questions will need diagram. I'll show you a couple of them today. And do them slowly. Once you have the confidence, and see, very frankly, in fact, if you notice up till now, I have not used too many concepts of time, speed, distance. The major concepts of time, speed, distance come mainly in races and all. Up till now, I have more or less only used formula, distance is speed into time and so on. Up till now, that I have used that only. Yes, there are other questions I will use concepts. So that's it. Okay. Everybody else getting things? If there is anything, please let me know. I'm just moving ahead with the next question. One escalator question, we normally people keep asking us escalator questions, or escalator questions are very difficult. I think escalator questions are very easy if done smartly. Okay. Think of only one thing. When escalator is going up and you are also going up, the escalator is helping you. So the speeds will add up. If you are going up, escalator is coming down. Escalator is against you. So speeds will be subtracted. And even if you are going down, escalator coming up, speed will be subtracted. Right? So let's look at this question. Moody takes around 30 seconds to finish riding an escalator. If he walks on its normal speed in the same direction, which means the escalator is also going up, assume going up, he is also going up. So what you need to do in such questions, you need to allot the escalator some speed and the person some speed. So let us assume Moody's speed. Okay, Moody's speed is m and escalator's speed is e. This is Moody's regular speed because they said about normal speed. So with this speed, how many seconds is he taking to cover the whole distance? Now finally, don't look at the number of steps. Think of it as distance only. In 30 seconds, m at a speed of m plus e. In 30 seconds at a speed of m plus e, he is able to cover the whole distance, which means 30 multiplied by m plus e is my total distance to be travelled. That is 30 into m plus e is the total distance on the escalator. So leave that over here. He takes 20 seconds to finish riding the escalator if he walks at twice his normal speed. So if he doubles his speed, just because he is doubling, remember escalator doesn't double, escalator moves at the same speed. So his speed becomes 2m, escalator is still at e and same direction, so helping Moody. This time he takes only 20 seconds. So multiply by 20 and these both are also equal. Why are these both equal now? Because distance and distance. This is also the distance, This is also the distance only. Solve it out, cut 1 0 0 out and solve. So I'll get 3m plus 3e is equal to 4m plus 2e. If you solve carefully, you realize e and m are same. Great. Leave it over here. Let's see what have they asked for. If Moody decides to stand still on the escalator, then the time taken in seconds to finish riding the escalator. That means he does not work. He's just standing. So only the escalator is moving this time. Time taken. So the last step is like how you do time and work. In fact, a lot of this question is the way you do time and work. Okay. Because m is the work done by Moody, e is the work done by the escalator. Nothing else is changing. So what is the total distance? 30 into m plus e. But m is e only, so it will become e plus e 2e. This is the total distance. And in the last case, who has to cover this? See, Moody is just standing. So Moody becomes 0. Only the escalator is working. So hence you will divide by escalator. So hence it will take 60 seconds. If you notice this, there is so much of time and work in this question. Very frankly, a lot of question of escalators will be done exactly in the same concept, same way. Don't try any different stunts and all. Just keep trying to do the same thing. You will more or less get the distance either in terms of m or in terms of e. It will not matter. And more or less you will start getting the answers. Have a look at it. By the time I will read your chats, what have you all asked more? Okay, I think no more chats, no more discussion on the chat. If there is something, please ask. As I said, we can go. We can have a look at it. Escalator questions, have they been asked in the last couple of years? They have been asked, yes. In fact, this was a CAT 22 question. Yes, it's not asked in 23 and 24, but very frankly, 22 for CAT is like recent past. When you say CAT is asking a particular type of question in the recent past, if it's asked in the last 5 years, that is considered recent. Okay. So please go through escalator questions carefully. Don't just ignore them. Okay, let's continue. One more CAT 21 question. Now, let's have a look at the question. Two trains cross each other in 14 seconds when running in opposite direction. Two trains cross each other in 14 seconds when running in opposite directions along parallel tracks. So, when they're running along parallel tracks, if they're running in opposite, now this is a very standard question. Here you need to know concepts. That is why I will go slowly. The faster train is 160 meter long and crosses a lamp post in 12 seconds. Now, sometimes in time speed distance, I have to identify which statement should I use first. So, very clearly, the faster train is 160 meters long. So, I've been given the length of the faster train, 160 meters. And it crosses only a lamp post. Let's assume this is a lamp post. This is a train. It crosses the lamp post. That means I have to consider only the length of the train. The length of the train crosses the lamp post in how many seconds? In 12 seconds. So, I would do it this way. Time taken by the faster train, which we know is 12, is length of the train divided by speed of the train. Remember, there are no two trains over here and there are no two lengths also over here. Normally, for all time speed distance of train type of questions, I tell only one formula. I say time taken is L1 plus L2 upon relative speed. And now you will say, sir, but how will it work over here? It will still work. Let's see. What is the time taken to cross the pole? 12 seconds. So let's take that as 12. What is L1? Length of the train, 160 meters. Does the pole have a length? No, the pole has a height. The pole has no length. So the length of the pole is 0. Relative speed. One of the objects is stationary. The pole is stationary. The pole is not going anywhere. So it will be speed of the train, speed of the faster train, let's call it as SF suppose, plus 0. So if you use only this concept every single time also, it will come right. So what will you get? So SF is equal to 160 upon 12, which is 40 upon 3 meter per second, speed of the faster train. What have they told further? If you read carefully, they have said the slower train is speed is 6 km per hour less than the faster train. So what will become the speed of the slower train? 40 upon 3 is the speed of the faster train, minus 6, but both are in different units. This is in meters per second while that is in kilometers per hour. So convert. So minus 6 into 5 by 18. Whenever you need to convert kilometers per hour to meters per second, you need to multiply by 5 by 18. That will be 6 3s are. So 40 upon 3 minus 5 by 3 will become 35 upon 3. That is the speed of the slower train will be 35 upon 3. Right? So that's speed of the slower train. Now I will go back and read the earlier condition where they have said, what have they asked for? Read. Is the speed of the other train is 6? What is the length of the other train? Now again, if I use the same concept over here for both the trains together crossing each other, two trains cross each other in 14 seconds. So time is 14. Length of the first train plus length of the second train. I already know length of the first train 160. Length of the second train I don't know. Upon relative speed, what is the direction? Is it opposite or is it same? When opposite, you will add. I'm sure you'll all travel by train. When your two trains are going opposite to each other, the relative speed is much higher, so you have to add the speeds. So it will be 40 upon 3 plus 35 upon 3. 40 upon 3 for the first train, 35 upon 3 for the second train. So it will become 75 upon 3. 75 upon 3 is 25. 14 into 25. I think that should be 350. Yeah, 14 into 25, right? 14 into 20 is 280. And 14 into 5 is 70. 280 plus 70, 350. 350 minus 160 is L2, which is the length of the second train. And length of the second train is 190 meters. One concept. The whole train thing can be done only by this one concept. Whether the train is crossing a bridge. Now see, let me explain to you. If the train is crossing a bridge, only one object is moving the train. But both the objects have a length now. So you will have L1 as well as L2, but speed is only for one object. When two trains are moving, there is L1, there is L2, and both the speeds are there. So denominator will either have S1 plus S2 or S1 minus S2. Okay. So don't worry about that. And this is how you find, in this case, L2. Have a look at the question. I'll just have a look at the questions. What you all have. So Vaishnavi in the previous question has, how is it 30 into 2E? Okay, because M and E were same, no? So if you noticed, Vaishnavi in the previous question, there was a point where we said 30 into M plus E is the total length of the escalator, or the distance the escalator is, which you have to travel. So instead of M, if I put E, E plus E will become 2E and 30 into 2E. So Vaishnavi, I hope I have answered that question of yours. Bhavna also had the same question. Bhavna, I hope that is clear. Yes, Deb, you could have used that concept also, because the speeds were, in one case it was M plus E, other case it was 2M plus E and so on. You could have done it. I have no issues with that also. Okay. Okay. Let's go to the next question. I had actually done the animation for this question, not used them. So maybe just you can see them in the background. Let's have a look at the next question. The next question is a slightly interesting question. The question looks difficult. You feel, oh, they're asking you something really different. And then suddenly the question kind of just happens. Two trains, I know people feel, sir, why doesn't it ever happen for us? It will happen with a lot of practice. Two trains A and B are moving in opposite direction with their speeds being in the ratio 5:3. So let speed of A be 5x. Let speed of B be 3x. Ratio is 5 and 3. So 5x and 3x. Now, the important part is over here. The front end A of A. The front end of A, suppose there are two trains. I'll just take one more object in my hand. Say, let's take my mobile. This is one object. This is the other object. The front end of A cross the rear end of B, and they are moving in opposite directions. Okay. Rear end of B 40 seconds after the front end of the trains had crossed each other. Now understand this, the front end of A crossed the rear end of B, not the rear end of A. So which is the length I will consider for this part? You have to read this at least 2-3 times to understand what they are trying to say. Whatever I have just put in the bracket, let's read that couple of times. The front end of A crossed the rear end of B 46 seconds after the front ends of the train had crossed. So after the two front ends crossed, then the front end of A crossed the rear end of B. That means only B's length is important. The rear end of A has still not come in. Okay, which means in the first case, when I will use 46 seconds, I will consider only length of B as the length to be considered for this question. And speed will be, obviously, because they are moving in opposite direction, it will be 5x plus 3x, so 8x. So therefore, length of B is 46 into 8x. Leave it over here. Don't even multiply it. If you are multiplying, you are wasting time. Now, if you read the second part of the question carefully, what have they said? It took another 69 seconds for the rear end of the trains to cross each other. Now, in this case, what will happen? The rear end of the trains to go. This time, the rear end of A also is crossed. So this time, I will consider another 69. So I will not consider B again. So 69 seconds more for length of A to be crossed again at the same relative speed 8x. Important was another 69. If they had said 69 from start, we would have done 69 minus 46. Another 69 seconds for the length of train A to cross over completely at same speed 8x. So therefore, length of A becomes 8x into 69 or 69 into 8x. What have they asked for? Read very carefully. Ratio of A to B. A to B ka ratio 8x into 69 upon 8x into 46. 8x cuts out. 23 3s are, 23 2s are, ratio is 3:2, which is the first option. Now, let's go through this one more time. The important point over here was to identify which length to consider in which case. That was the most important part. Now, this question can become like a literally level A, which can be solved under 1 minute if the question was understood. Otherwise, you will make a mistake and you can mark 2:3 also or something like that. So, please be careful. The front end of A crossed the rear end of B. That means the whole length of B was considered in that case. Okay. And that is why in first case we do length of B and second case we do length of A. Important question. Have a look at it properly again. Later on maybe you can just switch on YouTube again one more time, have a look at the question and try it one more time. Let's have a look at the next question. Now, this was a CAT 2018 question. I've done this question upteen number of times. I used to use this with last mile to CAT earlier. One of my favorite questions. Again, it's a question which looks very, very difficult, but done smartly, the question just happens. Point P lies between points A and B such that length of BP is thrice that of AP. So that's my first part. I drew, this is the place where I draw diagrams. Khushi was asking, Khushi, sometimes the sums don't happen. This type of the questions is where I draw the diagram. So I've taken ABP somewhere in between where BP is thrice of AP. So 1 and 3 I've taken, you can take it as 1D and 3D, nothing, it will not make a difference. Simultaneously, car 1 starts from A. So car 1 starts from here from A and goes towards B obviously, and simultaneously car 2 starts from B and goes towards A. Okay. Now that is okay. They just told that car 1 is going to go from A to B and the other car is going from B to A. Read this part very, very carefully. Car 2 reaches P 1 hour after car 1 reaches P. Car 2, so A will reach, the first car will reach P. At that time, the second car is still behind, not reached P yet. There could be two reasons. The second car is slower, or the other reason is because this distance is higher, it took more time. All that we'll see later, they must have told something. If the speed of car 2 is half of car 1, very important. Speed of car 2 is half the speed of car 1. This was very, very important. Now look at the diagram and tell me very carefully and think in your mind. When car 1 goes from A till P, it has covered a total distance of 1. But because speed of car 2 is half, by that time, that means by the time car 1 reaches point P, Whereas car 2 reached only this point, let's call it as say C. It has reached only point C, which is only 0.5. Why 0.5? Because half of 1. So in short, if your speed is half of my speed, if I can cover a distance of 1, you can cover a distance of 0.5. So car 2 is half of car 1, and that is when car 1 covers 1, car 2 covers only 0.5 in that much. So by the time, now listen to this again very carefully, by the time car 1 has reached P, car 2 has reached only C. So how much more distance is left for car 2? How much more distance is left for car 2? 3 minus 0.5, which will be 2.5. And this 2.5, they have told us it covers in 60 minutes, which is 1 hour. They told us in the question, right? Car 2 reaches P 1 hour after car 1 reaches P. So car 2 covers, I'll repeat this, car 2 covers 2.5, whether it's kilometers, meters, doesn't matter, units don't matter. It covers 2.5 in 60 minutes. So it covers 2.5 distance in 60 minutes. So let's find out how much time did it take for this part. So 0.5 distance it will cover in how much minute? This is 1/5. 0.5 is 1/5 of 2.5. So this will also become 1/5. So it will cover in 12 minutes. So car 2 reaches from B to C in 12 minutes, because for the remaining distance, which was 2.5, it took 60 minutes. So for the earlier distance of 0.5, it took 12 minutes. And let's read the question, what was asked in the question. Find the time in minutes taken by car 1 to reach P. So by the time anyway the car 2 had reached point C, car 1 had reached point P. So that answer is also 12 minutes. Or in other words, if car 2 takes 12 minutes for 0.5, car 1 will take 12 minutes for 1, because speed is double, because car 1 ka speed is double. Very, very, very nice question, because the question barely had any calculations. If you look, the amount of calculation in this sum is like literally zero. Only one calculation we did about this part, 1/5, and that's it. The whole question done differently can look very bad. Understand the question well, do it really well, and I'm sure you'll get it. Have a look at it. I'm just leaving it on the screen for a minute so that you all can have a look at it. I'll look at your doubts by then. One minute. Your doubts, I'm just searching for them. Yeah, I got them. Palakshi had asked why not LA plus LB in the second case. I'm assuming she's talking about the train question. Palakshi, obviously because we have already considered the length of train B, and that is why only length of train A was left to be covered. That's the reason. Same Abhinav was also asked, so I explained that. Clock question, Sarthak, I will take it up with, as I said, I'll take one more session later for races. At that time, I'll definitely take up clocks question also. Good point. So, Sharan, Sharan's question, I get confused while writing the equation and taking it further. So, just put down the equation in terms of always distance is speed into time, whatever. So, even if this question which you look at, which is there on the screen right now, you can do it with equations. I don't know, I've never tried it with equation. If you want, I can just try it with equations, and we can work on this question through equation. Suppose if I take speed of car 1 or speed of car 2 as x, so speed of car 1 will become 2x because they're told half and 2 times, right? Distance from A to P is 1. So what will be time taken? 1 upon 2x. But anyways, because this, that is the whole logic. But now I've done this question so many times by this method, I'm going to be able to think of this approach only. Very rarely will I be able to think of equation. Or I could just take time taken to reach P as t. So 2x into t is same as x into t, which is equal come out to be 0.5, and hence 2.5 is left. So just write the equation in this format always. Try and avoid fractions as far as possible. You will start getting questions. Let's have a look at the next question. A straight road connects points A and B. Now this is a particular concept which has been asked in CAT recently 3-4 times. So this is an important concept. I think this is also a CAT 21 question. Please go through it very carefully and understand it. A straight road connects point A and B. Car 1 travels from A to B and car 2 travels from, so this is same part, not necessarily P is at that point, it could be anywhere. Okay, car 1 is traveling from A to B and car 2 is traveling from B to A. They first both meet at P. They both meet at P. Now important point is they meet at P means they take the same time. So car 2 has say taken T hours. Car 2 has taken T hours. So car 1 also has taken T hours. This is before meeting. So whatever I am writing above the line is before meeting. Now let's read further. After meeting each, and it's in minutes, so not hours, so we'll take this as minutes, T minutes and T minutes. After meeting each other, they take 45 minutes and 20 minutes respectively to complete the journey. That means after meeting, car 1 reaches B in 45 minutes and car 2 reaches B in 20 minutes. If you want, you can just write that over here. This is after meeting. So let me explain this logic to you. There is a formula for this directly, which I will teach you how to apply it. But without the formula, how would you do it? Let's assume you don't know the formula. In case 1, let's look at car, the green car, as I would say. Green car went from A to P in T minutes, and then it went from P to B in 45 minutes. While the red car went from B to P in T minutes, and then it went from P to A in 20 minutes. For a constant distance, if I take the ratio of the time, I'll get ratio of the speed also. That means if I take T upon 20, what will T upon 20 become? T upon 20 will be the ratio of the speeds of A and B, car 1 and car 2. And if I now take again, if I have taken A and top and B and down, I'll have to do it the same way. Second time for the same other constant distance, it will be 45 upon T. If I cross multiply this, I'll get T square is 900, 45 into 20 is 900, and therefore T will come out to be 30. Read the question very carefully. What have they asked for? If car 1, so now I know if I put this 30 over here, 30 upon 20, 3 upon 2 is car 1 is to car 2 ka speed. 3 upon 2 is car 1 is to car 2 ka speed. If car 1 travels at 60, sorry, 2 upon 3, not 3 upon 2, it will be reciprocal, my bad. It will be 2 upon 3 because if distance is constant, speed and time will be reciprocal because distance is speed into time. Okay. So 2 upon 3. Now, car 1 travels at a speed of 60. This I already know is 60. So 2 is 60. Then how much will be 3? So if 2 is 60, 1 is 30. So 3 will be 90, which is the fourth option. One of the ways to do it. I assumed I did not know the formula. There is a formula for this question. Initial assumption was that I did not know the formula. But you should know the formula. What is with the formula? Let's have a look at it. With the formula, the concept is speed 1 upon speed 2 is root of T2 upon T1. Root of T2 upon T1 is the where T1 and T2, I will not be able to write, or I'll write it over here, where T1 and T2 are the time after meeting. Very, very, very important. Very important concept. So if you know this concept, you could directly apply this. S1 upon S2 is root of T2 upon T1. Which will be, and I know S1 is 60, so 60 upon S2 is root of 20 upon 45. 5 4s are 5 9s are. How much is square root of 4 upon 9? 2 upon 3. So 60 upon S2 is equal to 2 upon 3, and therefore S2 becomes 90. Very, very, very important question and very important concept. This particular concept, last 2 years in CAT, has been asked, I think, nearly in all the slots. If not all, but at least one or two slots they've always asked. So please go through this concept very well. And if you're an IMS student, you could also go through the concept video of this. We've created a concept video around this. Okay, have a look at the question. So somebody saying, is it possible now for CAT 25? Why not? We are, let's assume, end of May. Even if you start, say, today or by 1st June, you have June, July, August, September, October, and nearly the whole of November. 6 months. If you study, that's the only thing you're doing. If you're also working, it is going to be a little bit difficult. I'm not saying it's impossible, but it will be a little bit difficult. For the ones who are doing only CAT, 6 months is a very good time to study. In fact, I think this is the best zone to prepare yourself for CAT. If you're not doing anything and preparing only for CAT. So I'll explain this ratio part one more time. Basically, what is the concept? That if distance is constant, I'll just explain, not for this sum alone, but for in general the concept. When distance is constant, then time 1 upon time 2 is S2 upon S1. That's the ratio concept. That is in general. For this question, speed 1 upon speed 2 is root of T2 upon T1, where T1 and T2 are the time taken after meeting. This is a very specific concept. So use it only for these questions, these type of questions. Okay, remember that. I hope, Raj, that's clear. Okay, let's go ahead. Yeah, I think with that we have finished with all the questions. So if people have questions around the general discussion, I can take some questions. I'll just wait a couple of minutes and we can take general discussion questions. The questions which I had to do, 7 questions are done. We maybe have another 10 minutes where I can always take 10-15 minutes where I can take some questions. And as I said, I could not take the questions which you all had posted, but if you all have any general queries, I can take them. I'll have a look at if people have posted any general queries earlier. Circular races, somebody has asked, Yashvi has asked circular races. As I promised, I will take up one more session for races later. Concept of swimming pool, A and B starting from opposite ends. Fair enough, it's a decent concept. We can take it up with races again. Yeah, I think Divyansh, what you asked, I have more or less answered the ratio thing by reciprocals and so on. You have to be very careful. No, I think linear is very easy. Ramya, you should definitely be looking at solving them. Practice them well. I think you will get it. Okay. Simran has posted 2 questions around races, which, as I said, I'll take them definitely in the next time. Okay. So just waiting. If people have some more doubts, we can take them up. Can we go through all the questions focusing on the crux? So see, if you very frankly first go through all the, most of y'all, I don't know whether all of y'all are IMS students or not, but if you're an IMS student, you first go through all the concepts of time, speed, distance. In fact, at some stage, you'll also have to know time, speed, distance with geometry well. So there's a classic CAT 2008 question where there is geometry involved with time, speed, distance and so on. You have to know all those things also well. So Viraj, I've taken up 7 questions today, maybe another 7, 8 next time when we have one more session. Somebody is asking, sir, how I'm taking SimCats, how to judge your performance on the basis of a score or some other criteria. So let's now talk a little bit about SimCats. If you're taking the SimCats, the next 2-3 things which you need to do. Now this is something which I also learned, way back when I started teaching in 2004, 2005, and a lot of students would come up and say what we do. And afterwards, even when felicitations happen, we meet students who go into the IIMs and all that. Every time you take a SimCat, you need to analyze it really well. If you take 2 hours to write a SimCat, you should be taking minimum 3 to 4 hours to analyze the SimCat, because now you also have video solutions to have a look at. So have a look at the video solutions. How is the professor thought of the method, or how is say some faculty reading the RC, what are they reading which you missed out, or in a particular question what did they understand. So read that part. Also at the end of the SIMCAT, we also give you an analysis of that SIMCAT, which were the easy questions, which were the doable questions, which I just recorded day before yesterday, like a half an hour video on SIMCAT 1. Have a look at that SIMCAT 1 ka video, also half an hour video. I'm sure that will help you. Okay. So Kiran, I think that's also your question, so should be able to help you with that. Okay, I think we'll wind up for the day then. Best of luck everybody, and thank you so much for the session. You can post your doubts. You can post your doubts on the same chat. I will try and answer them. Best of luck.